students, today in this video I will demonstrate how to cube a natural number and also I will discuss about some interesting patterns of cube numbers. You already know a cube is a solid figure with 6 identical squares and it is also called as regular hexahedron. Regarding cubes, you will come across many real-life examples such as six-sided dice, a Rubik's cube, etc. Now, let's make cubic shapes using these unit cubes. Here is a unit cube. The next one is a cube with side 2 units length. 2 times 2 times 2 gives us 8. So we need 8 unit cubes. Similarly, we need 27 unit cubes to form a cube of side 3 units. Then, what about the next cube? So we require 64 unit cubes to form a cube of side 4 units. Now guess, how many unit cubes are required to make a cube whose side is 5 units? Obviously, you will need 125 unit cubes. So we require 1, 8, 27, 64, 125, 216 and so on unit cubes to make cubic shapes. Now let's see how to cube a number. To cube a number, just multiply it 3 times by itself. Here are the first few cube numbers. As 1 cube is 1 itself, 2 cubed is 2 times 2 times 2 gives us 8. Similarly 3. And even for 4 cubed, when 4 multiplied by itself 3 times gives us 64. Similarly, the cube of 5 is 125, the cube of 6 is 216 and so on. So, a cube number is obtained when a number is multiplied by itself for 3 times. So the numbers 1, 8, 27, 64, 125, 216, 343 and so on are called cubic numbers or perfect cubes. Here is the list of cubes of numbers from 1 to 30. Did you find anything interesting from the table? Just observe the table. We see that if a number ends in the digits 1, 4, 5, 6, 9, its cube also ends in the digits 1, 4, 5, 6 and 9. We can also observe that if a number has 2 in its units place, its cube has 8 in the units place. And if a number has 8 in the units place, then its cube has 2 in the units place. If a number ends in 0, its cube ends in 3 zeros. And also, if a number has 7 in the units place, its cube has 3 in its units place. And the same repeats for 3. We can also observe that the cubes of odd numbers are odd and those of even numbers are even. Here I have noted down the properties of perfect cubes. Now we will see some interesting patterns they form. Just look at this pattern. 1 cubed is 1. Here there is only one odd number, that is 1. Now by adding 3 and 5 we will get 8. Here there are two odd numbers. Now we are adding the next three consecutive odd numbers, that is 7, 9 and 11. We will get 27, that is 3 cubed. Again 13 plus 15 plus 17 plus 19 gives us 64, that is 4 cubed. And similarly 21 plus 23 plus 25 plus 27 plus 29 gives us 125, that is 5 cubed. So it's in pattern in which no number is repeated and all these numbers are consecutive odd numbers. Here for 1 cubed there is only one odd number, and for 2 cubed we have two odd numbers, here 3 odd numbers, and here 4 odd numbers, and obviously for 5 cubed there are 5 odd numbers. Now try to answer this. How many consecutive odd numbers will be needed to obtain as 9 cubed? Now you can answer this very easily with the help of this pattern. The answer will be 9. Here we notice that a perfect cube can be expressed as the sum of odd consecutive numbers. Let's move ahead to see one more interesting pattern. To calculate the common difference, you will find a simple rule here. That is 2 cubed minus 1 cubed equal to 1 plus 2 times 1 times 3 equals 7. And 3 cubed minus 2 cubed equal to 1 plus 3 times 2 times 3. And again 4 cubed minus 3 cubed equal to 1 plus 4 times 3 times 3. We can see a pattern here. Now you can find easily the next sequence. The pattern continues. Here the pattern is continued by multiplying by 3 each time and 1 is added to the product. Even we can generalize this pattern with an algebraic expression, that is n cubed minus n minus 1 whole cubed equal to 1 plus n into n minus 1 into 3, where n is a natural number. From this pattern, we can find the difference of the cube successive natural numbers without actually finding the cubes of the numbers. You can pause the video for a while to find the values. The answers are here. If you get the correct answers, then you are done with this concept. No poison can kill a positive thinker and no medicine can save a negative thinker.